This is Catalog and Cocktails,
presented by Data.World.
Hello and welcome. It's time for Catalog and Cocktails. Honest, no BS, non-salesy conversation about enterprise data and analytics, presented by Data.World, the data catalog for leveraging agile data governance to give power to people and data. I'm Tim Gasper, longtime data nerd and product guy at Data.World, joined by Juan.
Hey, I'm Juan Cicada, principal scientist here at Data.World. And today, this is a different episode. We are coming to you from our office at Data.World, but we are not live. This is a bonus episode that we're doing, and we're dropping this off brand new. We've been so thrilled and honored about how everybody has been listening to the podcast. We have so many people who are listening to it. They're reaching out to it. And we have so many people, guests who want to be on it. And it sucks to say no. So we're not going to say no.
Yeah, we want to bring more amazing content to you and amazing people talking about really key and important things in data.
And with that, I am super excited to introduce John Kutay. Did I pronounce your last name right?
Close enough.
How are you doing, John?
Hey, Juan. Hey, Tim. Hey, thanks so much for having me today. My name's, just for everyone, my name is John Kutay, product at Striim. And I also host my own podcast, not competitive with yours, but it's called What's New in Data. How's it going today?
I don't think podcasts compete. I mean, it's just more and more knowledge that we have out there, that we need out there. And it's just great that we have the opportunities to be able to go spend time and talk to great people. At the end of the day, we're just so lucky that we get to talk to folks like you and get to learn and just have all these great conversations. But all right, we're still, this is just like a normal episode. What are we drinking? What are we toasting for today? John, how about you?
Hey, for me, my drug of choice is caffeine. I got my homemade latte. I'm doing a lot of espresso brewing. So yeah, just enjoying this while we go into this episode.
That's awesome. I am also a caffeine aficionado, and I am not doing my own espresso and making lattes and things like that, but I want to. So we're gonna have to connect on that. You're gonna have to tell me what you're using for that.
Oh yeah.
What are you up to, Tim?
So I'm drinking this Domingo Mimosa Sour by New Belgium. It is a sour beer, and it's got a strong citrus hit. Very light, very interesting. I don't usually go for sour beers, but this is very cool.
Yeah. I could not do that. I think it's an acquired taste. I'm actually taking it really easy. I'll be very honest. Yesterday we had like a lot. It was an interesting night, so I'm just hydrating a lot right now. So.
An interesting night of lots of data activity and some drinking too. Right?
There was. And I'm toasting. This is our first bonus episode. We're doing this. So thanks, John, for being our inaugural guest for this. So thank you so much, and toast to you here for being a guest.
Yeah, cheers.
Yeah, cheers. Thanks for having me. And yeah, couldn't be a better topic to do a bonus new episode on.
Yeah,
absolutely.
So we have our funny question today. In one sentence, describe the most bizarre lucid dream you've ever had.
Yeah, the most bizarre dream I've had, and it seemed pretty lucid. It was at the height of the COVID pandemic, and we were all working from home on Zooms all day, and we had just gotten a puppy. And I had this weird dream about having to schedule a Zoom with my dog to feed him and take him on a walk. It didn't make any sense when I woke up, but just I think something about the Zoom world and having a dog, I was like, oh yeah, I have to like schedule a Zoom with my dog. Yeah.
That's pretty funny.
How about you, Tim?
So my weird lucid dream is, and this actually happened a couple of weeks ago, I was taking a test and everybody was turning in their tests, but I was just getting started. So it's some kind of a stress dream, right? But I remember it very vividly. And then I look up and the proctor of the test is my boss, John Loyens. He's the one who's making me take this test. You know what? That doesn't make any sense. Why am I having a stress dream? John is awesome to work with. So anyways, that was my really weird lucid dream.
Well, you know what? I don't remember dreams. My wife and I have a discussion all the time because she remembers all her dreams. She describes them, and I'm like, I think I remember dreaming, but then like I wake up and they're gone. So actually, I have nothing to share because I don't remember.
No, interesting.
Yeah. All right. Well, let's start.
You're living the dream.
I'm living the dream. Yes, that is. Maybe
Hey,
some
I
lucid
like
things
that.
happened yesterday. I don't remember. Anyways.
Yeah.
All right, John. All right. Honest, no BS. We talk about data streaming, stream processing, real-time analytics, operational analytics. What is the difference between all this stuff?
Yeah. So, you touched on a lot of cool points there, a lot of cool subjects. Just to start with data streaming is very simply the pattern of collecting data as it's new and only capturing what's changed from source systems and processing it in real time, sequentially as an event-driven architecture. Now that's applied in a few ways, one of which is operational analytics, situations where, let's say I'm a major airline and I have real-time maintenance data on every single plane that lands. Like that's an event-driven system. You want to take action on maintenance data as it's entered into the system, and there's a real-time SLA around it. I can get into how data streaming meets real SLAs and all these business objectives. But I would say, the core thing is just capturing that data in an event-driven fashion.
We were having this discussion yesterday on the podcast about sensor data came up, and we started talking about real time. And the discussion there was real time is subjective because real time is, for somebody, real time is every second, but real time can be 10, 15 minutes or whatever. How are you seeing that folks that you work with, your colleagues, your customer stuff, how is real time defined? And what do people expect by real time?
Mm-hmm.
So I actually see two flavors of this. And I would say the distinction is the one that's most common that we see in, let's say, the modern data stack or the cloud analytics world is near real-time analytics on fresh data. So that means, hey, I want to take my warehouse syncs, like let's say I'm running Snowflake or I'm running BigQuery, doing analytics there. I have all these business intelligence users who are running reports. Near real-time analytics on fresh data just means I'm bringing those sync frequencies down to, let's say, 5, 10, 15 minutes. That's like the low-hanging fruit for most companies. And for a lot of companies, it gets the job done. That at least gives all the end users and analysts confidence that, hey, when I pull a report, I'm actually looking at something that's pretty much fresh. Like we're talking about like within like last 5, 10 minutes. And there's a way to monitor this, your actual data freshness SLAs. So that's one area. The other is like true real-time data streaming, which I also see where like seconds and milliseconds of data delivery frequencies, mostly see with message bus systems like, hey, I stayed into Kafka, and then that's going to go into some, Spark job or Spark streaming and, machine learning that's going to update some model and kick off some workloads or send some alerts and notifications. That's where I see more like true real time in the millisecond context.
Interesting. And so you're saying that like a lot of companies may be, doing more of this near real time stuff. Then there's use cases that are more streaming oriented. And you mentioned a few things like alerts and things like that. Can you go in a little bit more detail of like when would you be doing more of a near real time kind of approach, and when would you be doing more of a streaming kind of approach?
I want to drill down into the use cases because we hear this all the time. Like, oh yes, we want to go have real time, but really, is it crucial or is it nice to have? And like, are we leaving money on the table because we're not being real time, or is it just it would be really cool, but do I really need to know exactly how many people are in this site or whatever, or this how many people just pay for something? Like, what are those use cases? And let's get truly honest, no BS on this stuff, because this is where I honestly feel that people are like pushing real time a lot when it's like, do you really need to go through that? I don't know.
Right. When do I need to take what approach? And hopefully we can break through.
All right, let's go demystify some stuff here.
Let's do it. So I'll give you a real real-time use case. So one of the customers we work with is a major retailer. A lot of their infrastructure is on-premise inventory management systems say, okay, tracking all our shipments, tracking the stock of all our goods. And then they have a whole consumer application suite that faces their customers. And the real materialization of this is like, okay, you have some mobile app where you're shopping for clothes, or you're on Amazon or whatever, some mobile app where you're actually seeing like what you can shop for, what the inventory is. So for those companies, they actually need a real-time source of truth for inventory. And inventory infrastructure from a data standpoint can be complex. It can be very disparate. It's going across different warehouses, different data centers, different clouds. And they want to sync that all in real time to the back end for their consumer facing applications, because you don't want to give customers a bad experience where they think that they're buying something that's in stock, going to be delivered in 1-2 days. But the truth is that's actually stale data. They're out of stock. Next thing you know, they say, oh, we're actually ship that to you in 4 to 6 weeks. We were wrong when we said it was in stock. So that's a real example of how real-time data can influence customer experiences and really does impact your bottom line and your net promoter scores and all that types of stuff. So we see that a lot. We do have some case studies on the Striim website, Striim spelled STRIIM.com, where some major retailers and other operational companies have deployed real time to build better customer experiences. So that's one classic problem. Yeah.
So that's sort of your example where if it was in 5, 10, 15, 30 minutes, that wouldn't be in time, because by the time that person has made that purchase, now that mobile app essentially lied to them. And maybe some companies can just handle that with back order, but a lot of companies want to actually allocate the correct inventory towards the particular shopping cart, right?
What about
exactly?
When are the situations where people would think you need streaming or real time, and it's like actually not the right thing to go do?
Like a common misconception when you're like, oh, like
anti-pattern.
Do I need streaming? It's like, well, no, actually, you could do that in batch, or you could do that in fast batch, or whatever, right?
I always recommend to customers, like if the data is going into a data warehouse, think about cost, and because Striim does work with a lot of customers who are quote unquote streaming data, but into a warehouse. And we work with them to make sure that their sync frequencies and merges and all that stuff is actually like sane, because if they're doing like merges every single second, I mean, they're going to be, tripling or quadrupling their warehousing costs. And it doesn't really make sense when their end users are just people pulling up a report. In that case, you can optimize for costs and say, okay, just do the sync frequencies on like a 15 to 30 minute interval. If the only thing that's going to happen is you just have some users who are going to pull up a report in Looker or Power BI or something like that.
Yeah, this is an interesting point, is balancing the costs. And I think we all get excited about, oh, let's get this now, and the technology's there to go do that. But hey, let's remember that there's a cost. We got to go pay. And at the end of the day, like, what is the value out of it? And I think this goes back to like, we talk about this all the time. Like, what is the business problem that this technology is helping? Do we really need to be able to go do some sort of analytics over this in real time? So going back to your example, you said like the retailer, that's more, I see this more as kind of real-time transactional. Is there a real-time analytics when it comes to do some sort of like analytical processing in real time? This is something I've personally been a bit confused is the necessity or kind of the use cases behind this. What are you seeing?
Yeah, that's such a great question. So, basically you're saying, hey, that's a transactional use case. We're just replicating actions and making sure those are in sync. And you're totally right that's kind of like the problem that, you saw like the 2000s era data integration vendors solve, like Golden Gate Software, who's owned by Oracle now. And, that's the founding team for Striim. Now everything, it's almost like having analytical models in between the raw data and then what customers are experiencing is becoming the de facto way of delivering data, where, hey, we're not just copying a transaction from, an inventory system and then putting it in another database and showing that to customers. you want to essentially personalize experiences. You have data on the customer across multiple SaaS applications, and you want to actually correlate that data between, let's say, they might have a record in Salesforce, they might have a record in your marketing system, your VIP loyalty system, and you want to build that real-time single source of truth, which does involve correlation, which does involve model building. It could be as simple as running some rules-based queries. And then making that a real-time source of truth does actually involve operational analytics.
Interesting. So that's an example of a use case. So these like personalized experiences that are based on maybe rules-based queries or something like that. That might be something where you need that event information. Yeah, I mean, it's a little bit semantics. Like, is that really kind of like transactional in nature, right? But in general, that's a very real-time analytical sort of use case.
Correct. What are they? Correct. And in that context, usually have some analytical models being trained in the process, or maybe it's just a warehouse dimension that you want to correlate from multiple systems.
Right. Okay.
Once you're doing that sort of model building in the warehouse, I think you cross the plane from purely transaction into analytical.
Okay.
I think we've mankind in a way has now changed so much to want things now, right? I mean, Amazon Prime, right? Delivery you get delivery in 2 hours now, right? So our expectation of getting everything now is leading us to think more about being real time. But I don't know. I still think that we were having this discussion with on a previous podcast here about effectively isn't everything could be just real time. It's just a difference of how you feel real time, right? Batch is very slow. It's not near real time, but it's some sort of a spectrum. So at the end of the day, it's not like it's either batch or it's real time. It's like a knob, right? So you decide how to go turn it on, and you put it faster, you put it slower. If it's slower, possibly it's cheaper. If it's faster, you get more of this other great data faster there, but probably need to go pay more around that stuff. Is that a good way of seeing it? That this is just one side, one spectrum, and just a knob that you're just turning?
It can be a knob, but once you try to get super real time, then you actually think about putting new architecture in, and that's what's scary about it. Because you would think that I'm in the batch world right now. Like right now, my sync frequency could be like 1 hour into my warehouse, and then I'll update my models every 2 hours. And now I'm thinking, okay, let's bring that down to 30 minutes. Let's bring that down to 15 minutes. Let's bring that down to 10 minutes. Boom, boom, everything will blow up because it's not designed to deal with data at that type of scale and speed. That's when companies start thinking about actual real-time infrastructure. And there's been a lot of good writing on this topic. Actually, and from DBT has a great write-up where, and that's very much in the nature of BS, very, very in line with this pod, where she says in most cases you don't need it, but here's where you really do need it, and don't even try to do this with batch because it won't work. And it is an operational analytics use case that she's referring to. It's a good blog post that I'll share a link with y'all later that you can repost. But
that'd be
lots
awesome.
of good examples of this. Yeah, Amy Chen from DB.
But,
awesome.
But from a user perspective, I just want it to be a knob. Like, why do I get that from a technical point of view, there's differences, architectural point of views, but I don't care. Like, just make it transparent for me. And because right now, I think this is kind of like my personal annoyance with all the entire stack and everything in the modern data stack and stuff. It's like, it's all over the place. And there's so many tools when like these things should be, I mean, I don't want to have two tools for this stuff. This should just be one tool which has a knob and I decided, and behind the scenes, the vendor figured out the best architecture for that. I mean, is that too crazy? I don't think so.
Well, no, I'm with you. You're crazy, but you're in a good way. And that's how we push boundaries here, right? And I'm 100% with you that for users it should be. And when I'm talking about users, maybe the data engineering end user who just wants to go from batch to real time, it should just be like just show me the knob, turn it down to from 60-minute syncs down to like 1 second syncs, and it should just work transparently. I'm 100% with that. I think that's where we need to go for if we're really going to deliver real time to companies at scale. When I mean scale, I don't mean just like the Ubers and the Googles of the world who can hire 50,000 PhDs to build this stuff out. I mean, every company should be able to implement the value of real-time data for their customers.
Got it. I think that makes sense. This is interesting. We're talking about, sort of which use cases fit in which modes and things like that. And some of the misconceptions around sort of, batch versus streaming versus fast batch and things like that. And real time, near time, real time versus streaming. Maybe let's talk a little bit more about the technology as well. Like, I know when in the spirit of streaming, you hear a lot about, message buses and queues. You hear about things like in memory versus, writing things to disk. Like, what is the technology, that people should really be thinking about, sort of broadly speaking, when we're thinking about streaming or real time, and what are some of the trade-offs here?
I always think unless you're starting with the source of the data, it's not even worth going after real time. So if you're only thinking about the message bus, you're already a little too far down the stack before you're solving real world problems. I start with the source, and when you're looking at the source, you need to build out mechanisms for efficient change data capture. Change data capture is the process of capturing what's changed from an operational system in an event-driven format, rather than pulling it as like batches on like 15, 30-minute interval. And the reason you want to change data capture, especially with databases, is with operational databases that have heavy in terms of the applications running on top of them, you don't want to put more strain on them by running queries on the database just for analytical purposes to pull what's changed. You want to basically go against the change logs. All databases write to what's called a write-ahead log, which puts it's basically a journal of all the transactions. And you can parse those transaction logs, just the data that's changed. And then you can feed that into a streaming system, like a Kafka, or, I think Red Panda is also becoming a popular alternative to Kafka. You're getting that data-driven format. So that's where I would really start. And change data capture, there's a lot of it for databases. There's a lot of options for it. Really being able to do it from the logs is what's critical. Now SaaS applications, Salesforce, for instance, has a CDC API now where you can just pull the changes versus doing batch style API calls against it. And I think we're going to see more SaaS applications support native CDCAs. But until we get there, what you're pretty much going to have to do is do those pool-based API requests and look at the timestamp and try to get what's changed based on that. So that's where you start. A lot of tools will abstract that for you. Striim, the product I work on, being one example, so you don't have to worry about doing that yourself. Piece is the message bus. So now there's a couple ways you can go about it. There's full in-memory streaming systems. Well, first we can say why in-memory versus disk-based. Memory is obviously faster. You don't, writing to disk, there's more IO. You have to do lookups against, the drive. Whereas when everything's in memory, for instance, with Striim's implementation, we just everything as like a sequential queue that's in memory and can run processing directly against that. And that's what gives you really fast performance, like millions of queries per second on the data that's flying through. And then finally, the way you egress that data, the way you write it out into external systems, like a data warehouse, or let's say like a Slack alert writer or whatever, you have to buffer that data into a format that can actually be handled by the data warehouse or because everything is like warehouses and databases and alerts, whatever it is, they're all kind of have batch extractions, ingesting data, and you have to format streaming data for that. Does that make sense?
Completely. I am so appreciative of what you just said, because I think you very clearly described kind of the implementations behind this, which I just learned a lot with what you just said. This is very, very important. And I know that I talked to a lot of folks that I talk to. I think streaming is something that is they want to discover more. So this was a really great.
Yeah, they want to understand the pieces a little bit, and I think change data capture is an interesting topic, because that's not something that I think traditionally, like you go back 10, 20, 30 years, like people talked a lot about change data capture. I feel like it's waned a little bit in sort of the knowledge. Like you don't hear modern data stack people talking a lot about like change data capture, but I feel like some of these traditional concepts are coming back with a vengeance now of like, oh, wait a second, remember that stuff we used to talk about? Yeah, it's actually still really valuable. And that's interesting to hear that even SaaS companies like Salesforce are starting to introduce that. Because, that was actually going to be one of my follow-up questions, is that in a world where a lot of things are coming from SaaS, it's actually a little more difficult to handle change data capture, because, databases write these things all the time, but SaaS systems, you may not have access to that information. So that's super interesting.
In digging in, another thing that I'm always, if I appreciate your clarification here, is when it comes to streaming and we look at things like the transformations and ETLs and DBTs, like, so broad question, what is the relationship between the streaming data and all these transformations that are occurring? Like, is this streaming or using DBT transfer models, or is ETL just another, is ETL becoming streaming too? Or, is that part of the knob? How, what is that relationship?
Yeah, that's a great question. And I do see, my goal is making streaming like as simple as, using your traditional batch, warehousing systems like Snowflake. And, to the end user, it should be just as simple, like you were saying. Right now, it's too complicated. Everything's too fragmented. Everything is such a low level abstraction where you have to learn, like, how to do the CDC yourself, how to, buffer the events in memory yourself, all that stuff. It shouldn't be that hard. Now, the relationship between, back to your question, like DBT, ETL, ELT, streaming, I still see a world where you're going to do a lot of ELT, like extract, load, transform, in a streaming format, in an event-driven format. And the type of transformation you're doing is like so low level that the user shouldn't even know about it. Like, we're literally just processing the data so that it's ingestible by a warehouse like Snowflake, and then your DBT teams will still do your model building on top of the warehouse, because for those types of use cases, it's simplest to just have all the data in the warehouse, build your models from there, have all the history of the data between pure raw data that I just loaded, and then my analytical models, whether it's like a slowly changing dimension or a fact table or whatever. The second category is if I actually need analytical model data in real time, I can't afford the latency of indexing in the warehouse, doing a merge, waiting for a DBT model to run on the warehouse. Like, we're talking about going from seconds of latency to minutes, and it could be like up to like 30 to 40 minutes, and it's not going to be cost optimized. So that is where kind of streaming can turn into ETL, where you're doing transformations and joins on the data in flight to build that analytical model in a streaming incremental fashion where everything's an insert. And I'm just feeding it into the warehouse, basically in real time, ready for analytics. And you can fire that off as alerts to operational systems like ServiceNow or Slack to say, hey, this is actually critical data and we need someone to act on it now.
If I look at ETL, ELT, is the E and the L would be batch versus streaming. So if we look at ELT, E and the EL could be batch and streaming, and then the T would be something that happens afterwards. So that would not be, that's after the real time or the batch. But then if I actually do ETL, right, then that means that the transformation needs to be done while in flight and the streaming. Is that a good way of seeing that distinction?
Exactly. It could either just be like a streaming EL, just fast data loads, or it could be a streaming ETL where I'm modeling the data the second that it's captured and loaded into downstream analytical systems.
Okay.
And on the no BS side, I still see much more of the streaming ELT, where we're just getting the data to the warehouse as fast as possible in an event-driven format, and most of the modeling is done after it's loaded. So I'm still seeing mostly ELT, but there's a lot of momentum, a lot of questions, a lot of new use cases coming out around streaming ETL now. So I'm personally keeping a pulse on that. I've seen some adoption, but definitely a lot of energy and interest in it now.
Say more of this. Can you give us? I mean, what are is it what are the use cases that you would want to go do streaming ETL? Because honest, no BS. Streaming ELT is really, as you just said, faster loading into the data into the warehouse than you're doing your analytics. So I'm just, but then itself, if I'm doing the transforms and that happens to be a model that needs to be built, it still takes whatever time, minutes, or 2 minutes to 20 minutes, whatever, to go build that. If effectively you're just building a view, right? And if it's a unmaterialized view, then if it's unmaterialized view, then you'll get the data as it comes in. If it's a materialized view, well, you got every time you go materialize it. So at the end, I don't care how fast I'm streaming things in. If I'm materializing it after the fact, that's not real time anymore. It's just whenever I materialize it. But then what are the use cases where you're doing like streaming ETL? Because it seems to me that I don't know. That's a question to you.
Exactly. Yeah. And that's a great point. Like, I've worked with one customer where we got like their ELT down from 30 minutes to an hour down to 5, all their materialized views and modeling happening in the warehouse. And that was a big win for them. But that's about as far as we go in terms of doing this in-house, just because, it's inherently a system. Not that there's anything wrong with that. There's a lot of advantages of batch. But the use cases for like streaming ETL are coming about with operational. I hate saying this word. Operationalizing the warehouse. We're talking about like reverse ETL, data activation type things, where I'm taking data from my analytical system. It doesn't have to be a warehouse. It could be any analytical system, and feeding that back in terms of engagement, as McKinsey calls it, like feeding it back into sales, feeding it into your email marketing campaigns. Like, you want to act on user data now, right? And that's where streaming ETL is becoming very interesting again, because we're basically taking analytical data modeled from what customers are doing, all these different sources, and now we're actioning it by feeding it back into some SaaS application or some user-facing application that's using that data to give them personalized offer, or fraud, or whatever it is. There's lots of operational use cases for it.
And just quickly, is this all still SQL?
Yes. Yeah. In Striim, it's all SQL.
Interesting. So, oh man, this is an interesting conversation. So I think we've got one sort of major question left for you before we kind of move to our lightning round. But just before we get to that, I just wanted to say that this episode is brought to you by Data.World, the data catalog for your data mesh, a whole new paradigm for data empowerment. To learn more, go to Data.World. John, wanted to ask you, so, we, in some of our conversations before we chatted here today, we talked a lot about, like Lineage, and how there's some interesting interplay between, like, what does Lineage mean in a streaming context, and what's, how do those things come together? And, is there something new to think about, like, the E and the T and the L in streaming in terms of how that connects to Lineage? So curious about your thoughts there.
Yeah, Lineage is super critical across a lot of industries, especially financial industries. Eric Broda, his last name is spelled Broda, has a lot of great writing on this. He was a longtime architect in financial services, and now he's writing a lot about data mesh. And I had him on a podcast episode recently. He was talking about how, for regulatory and compliance purposes, tracking the lineage of all the data that they're analyzing is required. I mean, they need to be able to tell you, how did you collect this data? What were all the intermediate processing steps it went through? What were all the external systems it ran through? And being able to see like the actual life cycle of every single record that a bank is storing. So that's like the enterprisey, highly regulated industry use case. Now, coming back to like a very simple use case that everyone can relate to. You're pulling up some report, right? And you're going to see some metric in a dashboard. And someone will say, how do we come up with that metric? Where, like, it looks cool. I don't know if it's right. Like, where do we get this data from? That's where Lineage comes back into play, because you basically want data engineering teams to be able to have visibility into how like a certain field was generated, and not just from the model in the warehouse that came up with that number, but what fed the warehouse. What was the source application, right? Was it a database? Was it a SaaS application? When was it read in? What were the transforms that fed it? What was the ETL tool that loaded it? Being able to do all that sort of like kind of reverse engineering of data that you see in your reports is a super critical use case for Lineage.
Is there a different way that you need to calculate lineage when it's in a streaming context? Because, like, for example, when you're looking at like databases, right, a lot of times people either think, okay, well, either that system is generating lineage, or more often like you're looking at the SQL code and you're like trying to parse the code and things like that. Like, is it often similar in the case of streaming? You're looking at like what those either SQL or other sort of transformations are and what those steps are, or is there something like, and it's just faster, it's just more that streaming paradigm, or is it actually different in some fundamental way?
Yeah. Because in the streaming system, everything is event driven, we can be super granular about the lineage of each event, and say, what table did it come from in the source database? What object in Salesforce? If it came from a change data capture record, what was the offset in the write ahead log? For this specific transaction, we can get that granular. But one of the things that's valuable is being able to see, what was the ETL workload that loaded this data? What was the streaming query that processed it and transformed it? Is the logic there accurate? Is it going to produce correct data? When it was loaded into the warehouse, was it just an insert, or was it a merge, like some sort of upsert? Being able to have all that information at an event level is really valuable for teams to go back and triage and give their business stakeholders confidence that the data acts. And that's one of the features that I spent a lot of time on at Striim, on our streaming gauge functions, that basically gives you all that data when you write it into the warehouse. We don't show you the link. We make that metadata available for like data.world to pick it up.
Yeah, this is a really interesting point, because you can now get into so much granular level of detail. But you got to be careful about it too, because do we need all of this stuff? Like, do we need all this level of detail? I mean, well,
especially in that regulatory use case, like I can see Eric brought a kind of the financial background. That's an obvious use case. But then I guess if you're trying to troubleshoot a specific, like why are these 10 events malformed in some way, then you can it becomes very operational in that sense, right?
Yeah, exactly. The more data, the more metadata, the better. Just so teams can go back and triage the lineage and say, yeah, this is correct. Or they can say, oh no, this query logic is actually wrong. I can go, troubleshoot and fix it. And now they know the data is correct. So yeah, I mean, I think it's definitely something that will arm data engineering teams to have more mission in terms of giving their BI users confidence in the data.
All right. Well, there's so much. I mean, again, streaming is something that I personally think it's going to just naturally come in without us realizing. And again, I'm going back to the whole knob thing. I think this is one day we'll realize, oh yeah, as you said to yourself, anybody should be able to go do streaming. And I think that's what's the exciting thing, that it's this quiet thing that has always been around, right? Because we've always had it. I mean, we've always moved things, and it's just the world is getting faster, right? We're expecting things now, so it's going to come, and it's starting to come right now. So I really appreciate it. We've had these discussions right now. So let's go move to our lightning round. So presented by Data.World, the enterprise data catalog for your data and knowledge. And I'm going to kick it off first. So Is streaming a better term than real-time analytics to describe the event-driven processing?
Yes.
Awesome.
Oh, you want me to, okay. Should I elaborate or is it lightning?
No.
If you have something you want to add.
Or is it maybe it's just yes and that's it?
Yes.
Perfect. That's the best kind of lightning round answer. That's the best kind. All right, next question. Are there industries which really have no real-time streaming use case?
No.
All right.
Okay, so all industries will have some sort of real-time use case.
So maybe varying degrees of applicability, but there's something for everyone.
All right.
Yeah, it's so horizontal in terms of the technology that I think that all industries have some use case for it.
Okay, that makes sense.
All right, next question. Will stream processing expand in popularity and functionality where it will actually handle batch use cases?
Yes. Yes, you'll see hybrid streaming and batch workloads in one pane of glass.
And is that coming more? Is there like the streaming tools doing batch, or the batch tools are going to do streaming? Is it who's getting to that battle, quote unquote, battle first?
The streaming tool, well, I actually see it going both ways. Snowflake coming out with streaming ingest, BigQuery having their own streaming ingest layer. And then you're going to see streaming tools work with those APIs very well, so that's very transparent to the user as to whether this is a streaming workload or a batch workload.
Interesting. I feel like this is a trend that's kind of resurfacing again. So my big thing in streaming was Apache Storm, and that was kind of like you could do it streaming, or you could actually build more of a batch topology. So that's interesting that we're kind of coming to that again. So all right, last lightning round question. All right, so there's some new streaming data warehouses coming out, like Materialize and Rocket Set, and then you even just mentioned just now things like Snowflake and others are starting to add some streaming capabilities to their feature sets. Do those compete? Do they compete with stream processing?
If this is a lightning round, I'll say yes.
But expand.
There's nuances. Yeah. Okay. There's nuances where
we need some context around this one. Yeah.
Well, yeah. I think if there's so I would say there's really two types of streaming: the streaming data streaming with movement, where it's really focused on bringing in, processing it, sending it to some other system, and then there's other things that are closer to databases, which is I'm just going to ingest streaming data, index it, and you're going to query me to get the real-time analytics rather than me sending it to like a Snowflake or a BigQuery. The product I work on is more on the former, where we're focusing on streaming movement and data integration. But yeah, we're going to see the data streaming databases get into it as well.
Interesting. Yeah, a lot of overlap, a lot of maybe confusion, but that's why we're here, right? To help cut through the BS and help us figure out what's going on. So this is good.
Yeah, the key is not to reinvent the wheel. Everyone has a warehouse today. Work with that first. Try to get it to as near real time as possible. See if that fits your needs, and then look into investing in like hard streaming databases or infrastructure.
Well, takeaway time, Tim. Tim, take us away with your takeaways. Go first.
Yeah, sure. So this has been awesome, John. I feel like I've learned a lot about streaming and sort of real time versus batch versus sort of real time stream processing, capture, change data capture. There's been a lot that we've covered today, which has been awesome. So just to start things off, you mentioned that of all those definitions, you kind of honed in on streaming. Like, what does it mean to do streaming data or streaming analytics? And you mentioned that it's the power of collecting data as it's new and processing it in a sequential manner, capturing it in an event-driven way and working with it in an event-driven way. And you gave an example of like doing maintenance related to airplanes, and you may want to have like the ability to sort of do real-time sort of monitoring and actions on that kind of data as an example of something that real-time streaming might make sense for. And we talked a little bit about like, well, what about near real time versus like true real time, right? Like what is real time? Is it 5 minutes? Is it 10 minutes? Is it 5 seconds? Is it milliseconds? And the answer sounds like it's kind of it depends, right? It depends on your use case, depends on what you're trying to do. When we're talking about streaming, it does sound like we're leaning a little bit more towards those use cases where you can, when you're being event driven, handle things in a pretty fast way. Get into those seconds, get into those milliseconds if needed, and then it kind of just depends on the use case, and that you can monitor this. And you kind of mentioned data freshness SLAs a few times in terms of that being very applicable to this. And then when you talked about streaming real time, you said it's usually message bus related, Spark, machine learning, alerts and notifications. These are the kinds of things that can often be use cases and things that will key off of streaming. And you gave that example of a major retailer where a mobile app might be being kept up to date with real-time inventory information. So that way, when somebody buys something, that they're not going to accidentally buy something that's not available or not in stock. And then, when is streaming not the right thing? You said, like, if you're using a data warehouse and you're like servicing a BI report and there isn't really a use case for, having that information be in, seconds or something like that, right? That's an example where if you were doing that, maybe that would be unnecessary from a cost standpoint or from a complexity standpoint, that there's really other use cases that are more appropriate for that streaming paradigm. So I thought those were some really interesting things there. Juan, what about you?
Well, the main thing for me is this whole knob, right? I think we agree on the vision that the knob should be from batch to real-time streaming. That today it's different. It's hard because there's very architectural differences around that. But the vision is that this, for the user, it should just be a knob. And I think we're going to get there sooner than later. So what we talk about underneath the hood of streaming. So message bus isn't the right starting point. It's the source, in particular, the change data capture. So looking at using write ahead logs and change logs and the journal of transactions. And we're seeing things like Salesforce, you said, have a CDC APIs. But I mean, until that, like with SaaS applications, you have to do everything in a pooled approach. We talked about a lot of the ETL, ELT on streaming, right? So if it's ELT, that EL is going to be the streaming, and that's just really fast loading, and then you're doing the transformation later into your data warehouse. But when you do ETL streaming, then you're literally doing that transformations on the data on the fly. So that's when you really have those real-time use cases where you need to do that type of modeling. And then, which is interesting when you bring in this lineage and streaming, is that you can really get into the much more granular events, right? Those event level lineage. And at the end of the day, more metadata is better. So we get that more granular level of details about what's going on. More metadata is better. It can help us answer a lot of questions. How do we do? What else? Anything we missed?
Yeah, those are amazing takeaways. It really sounded like you're able to ingest a lot from my talk in a streaming fashion.
It was very real time.
The one thing I'll say is if you're doing change data capture from a source system, you should always be streaming the data. You shouldn't be doing batches, because that's going to cause inaccuracies in your data, even if your end system is a warehouse. So that's like the one little caveat. If you're doing change data capture, you should always be streaming data, even if you're loading into a warehouse, ELT style.
That makes sense. And then you can read it in order, et cetera, right? Yep.
All right, John, back to you. 3 questions. What's your advice about data, about life? Second, who should we invite next? And third, what are the resources that you follow?
Yeah. My advice about both data and life, I come from a long time ago. I was a musician. I went to music school, San Francisco Conservatory of Music. And basically what I learned there is 5 to 10 minutes a day practicing your craft is better than marathon sessions every week or two. And when it comes to data, and it's the same thing, just spend 5-10 minutes a day just dedicated to learning and getting whatever it is you're trying to get better at. Yeah. And can you remind me the other questions? I lost them then. Yeah.
Who should we invite next?
Oh man, I have a lot of people. Have you had I know you've had Sarah Krasnick.
Yep.
Always worth inviting back. I would recommend her. Ethan Aaron, are you following him on LinkedIn? He
I
has some
am.
very, very cool takes. I know you have Chad Sanderson in the past. Those are all the people I follow, but you're already on top of that. Aaron's LinkedIn has a lot of great insights and a very contrarian view on topics, which I love to hear. And I think we in the data industry, we sometimes get a little trapped in hive mind. We need people like Ethan to keep us on our toes and really question some of the assumptions out there.
Yeah.
All right. Well, Ethan, if you're listening, we'll definitely invite you over. This is great. Now I've been following a lot of this stuff, and I think they were chatting with Joe and Matt yesterday, something about data contracts and stuff, which we're going to have Joe, Bryce, and Matthew are going to be on our podcast, on our live show next week, which is September 8th, I think. But finally, what resources do you follow? You mentioned some people who go follow on LinkedIn, like, blogs, books, podcasts, stuff. Like, share with everybody.
I definitely recommend my podcast, What's New in Data, and we really just focus on latest trends, and we have great guests. Joe Rice is coming on as well. I just picked up his book on data engineering. This weekend, Labor Day weekend, I've have it on my calendar to go through it, so I'm really excited to read it. Also read Zamani's data mesh book. I know there's a lot of there's so many opinions on data mesh, that seem a little uneducated flying around, and I really wish everyone just read her book because it really does clarify a lot of stuff. So that's a great resource as well. This podcast, Catalog and Cocktails, I love tuning into it. It's a great one, especially to get pretty much everyone who's a thought leader right now has been on this pod, so I'm really excited to keep listening.
No, absolutely. And plug your podcast too. Tell us about yours.
Yeah.
What's new in data? Just like Striim, we talk about what's changed, what's recent new in the data industry. We go live Wednesdays at noon Pacific. My episode, my episode on September 7th in context with Toad is going to be Seattle data guy. My most recent guest was Sarah Krasnick, and we've been relatively light in terms of just like trends, high level, just keeping people up with the late trends rather than diving too deep into a specific subject. I know there's a lot of great pods where people go deep on certain subjects. On what's new in data, we're trying to keep it like, okay, this is like a new term that's coming up. What is that? And just keeping people in sync with things. So you can follow that at Striim, STRIIM.com/podcast. You can subscribe to it there.
Well, if you want to have a really podcast day, so on Wednesdays you tune into your podcast, and then which is at 12 p.m. Pacific, 2 p.m. Central, and at 4 p.m. Central, we do Catalog and Cocktails live. So that can be a fun afternoon.
Amazing.
Podcast Wednesday.
There we
That's
go.
awesome. Yeah.
Man, if you went through those podcasts, you can learn a lot on Wednesdays. Yeah.
So it's a Wednesday, Learning Wednesdays. I love this.
Yep.
Well, hey, next week, whenever I think this is coming out this week, because it's the first time we're going to be pushing this bonus episode out. September 22nd is the Data.World Summit. Just sign up, go to Data.World. We're listing the schedule of all amazing speakers we have. It's going to be just a full day packed of so many different events, and we're going to be that week live from Big Data London. So that's going to be a fun week. And you will be there too, John. So we're going to probably cook up some really cool Catalog and Cocktails events. And looking forward to seeing you again. Saw you at Gartner. I saw you at Snowflake and then Big Data London. So thank you so much. Thank you. And as always, thanks to Data.World who lets us do this podcast, the data catalog for a successful cloud migration.
Yep.
Cheers, John.
Cheers, John.
Hey, cheers, Juan and Tim. Thanks so much for having me. Cheers to Data.World as well.
This is Catalog and Cocktails.
A special thanks to Data.World for supporting the show, Carly Berghoff for producing, John Loyens and Brian Jacob for the show music, and thank you to the entire Catalog and Cocktails fan base.